Okay, so to find the area between two curves, we're going to sketch a graph again. You can use your graphing calculator to help. So in y1, I'm going to put 2 minus x squared, and in y2, I'm going to put x. And now we're going to need to find where these two graphs intersect. So making my sketch, this is my f, this is g. So I want to find the area in between here. And that's going to be the integral from this point where they intersect to this point. So to find that, do second, calculate, intersect, arrow over to that spot, and hit enter 3 times. So this is at -2. So my integral is from -2, and then I'm going to calculate again. And that's at +1 here. And then looking at my picture, the graph that is always greater is f. So my integral is going to be f of x minus g of x dx. Now you can calculate that a few different ways. I could actually calculate what 2 minus x squared minus x equals, and then using our simple power rule, we could, and the fundamental theorem of calculus, calculate this integral. Or, since we have it here in our calculator, I can use the math menu, option 9, and my equation is going to be y1 minus y2, comma x, and I wanted the integral from -2 to 1. We get 4.5. That doesn't make sense. Yes, it does. Sorry, I was thinking because this was negative, we would want the total area, but I should read the directions carefully. We want the integral and the area between. So it will, if we just evaluate the integral, we'll get that area, so 4.5. So now we're going to do the same thing for b. So f I put in y1 and g I'm going to put in y2. I'm going to graph those. So my first function looks like this. That's the f of x. G of x looks like this. That's g of x. So when I'm looking for my integral, I'm going to have g of x minus f of x, because g is always on top. So to find this area, now I need to find these two intersection points. So using my calculator, you can do second, calc, intersect. This is at 0 for the x value, and this x value is at 3. So my integral is from 0 to 3. So I'm going to use my math option 9 again, and this time we're doing y2 minus minus y1. We get 9. Okay, we're going to do the same process for C and D. For C, I'm going to put this in y1, and this one in y2. Let's see what that looks like. Now that window, because I know my second graph is at 0, I'm actually going to do zoom decimal. It's a nice zoomed in window. Okay, there's my sketch, and then 0 is just the x-axis, so we want this portion and this portion. So finding the integrals, I'm going to have to do two pieces. First, I need to find all of these x-intercepts. This one's at -1, this one's at +1. If we hit trace, go over to -1, it's at 0. So my integral in this case, for this half, y1 is on top. So I'm going to do -1 to 0 of f minus g. But then for the next piece, I'm going to do 0 to 1 of g minus f, because in this case now 0 is on top and the graph is underneath. We can do that in our calculator as two separate integrals. So f is in y1. So I'm actually going to, if I hit second enter twice, I'm going to get back to that first one, which was y1 minus y2. And I'm going to change my lower and upper limits to -1 and 0. And we get 0.75, which is 3/4. Then I need y2 minus y1, so if I hit second enter again twice, now I have y2 minus y1, and I want to go from 0 to 1. That gives me a positive 3/4 again. So when I add those together, 0.7, in the calculator, 0.75 plus 0.75 is 1.5. And last but not least, D. So I put this in y1 and this one in y2. And I notice I'm going to have two separate sections again here. Let's see if we can make a better window. Can't quite see enough down here on the left, so I'm going to change my y minimum to -6. Okay, so I get a good enough idea to draw my picture. So I'm going to do f of x in blue. I'll do g of x in green. So again, my two different integrals, I need to find this intersection point, this one, and this one. So using the second calc intersect, I'm going to arrow over to the one on the left, enter 3 times, and this x value right here is -2. This one's at 0, and this one's going to be at +2. So I need the integral from -2 to 0 of f of x minus g of x. Then I would need the integral from 0 to 2 of g of x minus f of x, because now in this case g is on top. So what we're finding is this area and this area. So this is y1 minus y2, this one's y2 minus y1. Alright, y2 minus y1 is this, and I need that from 0 to 2. That is a value of 12. Then I have to find the other piece. I'm going to go back to my y1 minus y2. Here we go. y1 minus y2, and I need to do that from -2 to 0. And again, we get 12. So 12 plus 12, 24 is my total value.